So now step number 9, which is you have to go for data synthesis. Already you have extracted your data, you did risk of bias assessment. Now either quantitative or qualitative. So quantitative using meta-analysis, or sometimes we use mixed method, both. So what is meta-analysis? We have defined, let me have the pointer. We have defined the systematic review. What about the meta-analysis? So meta-analysis, it's statistical method that combines or pool all the data of the included studies in order to estimate an overall effect size. And I'll explain what is the final effect size. So it's statistical method, it's same, but we use Risk Manager instead of SPSS. And in this software, we pool the data of included studies of the same outcome, but they should have the same outcome. They should report the same outcomes. Okay. Another definition is qualitative evidence. So it's not qualitative; it's quantitative evidence synthesis and process of combining multiple studies, the included studies, to give one effect size with. This is the magic of systematic review of meta-analysis with large power. Because why? It has higher power, because higher sample size. So can you have a look to this first block? So this is the result of meta-analysis from Risk Manager. Even CML, it will give you similar shape. So this is the first plot. This is the raw data. And here at the bottom, we can see the analysis. So how many studies included? I can from, or I can also from here. But what I will explain the first plot in the next slides. But this is the final effect size. So this is the effect size of first study, second study, and so the Risk Manager, it combine and average the effect size of all study, and it gives you final effect size. So this effect size does, so this study, I cannot see. Okay. Is it favor? So it seems this study comparing between gastric bypass as intervention as compared to medical therapy for obesity. Let's say between orlistat as pharmacotherapeutic agent and between gastric bypass. So it's now which one have the effect size? It's significant towards or favor to gastric bypass. So gastric bypass has better effect in reducing body mass index. I'll explain that in later. So other definition, I think I'll escape, but it's, as I told, statistical method. We pulled all the data to get, but just only for high quality studies with that they are already evaluated or assessed based on the predefined eligibility criteria. So we get at the end final effect size with higher power. So it's pooling. We combine all the data. Since it's retrospective, so in this case we can reduce the bias by excluding those studies with high risk of bias, or if the study have problem with the validity, then we can. This is actually the good things about the final conclusion of meta-analysis. While for research study, we cannot do that because otherwise you have to repeat your experiment. Okay. The most important thing, we cannot do meta-analysis without systematic review. Why? Actually, theoretical, we can do it. You can just extract the data of 6 or 8 studies and run meta-analysis. It won't take 1 day or 2 days to do that. But you will not be able to publish that because it should be done under systematic review approach in order to ensure that you have followed all those steps. You have done the risk of bias, you have 2 authors, they have screened. So you use all those tools. Okay. When we can do meta-analysis and when we cannot do meta-analysis. So if there is kind of conflicting, we have to do meta-analysis. If the primary studies are too small, so sometimes why we conduct meta-analysis, we cannot have final conclusion based on just 1 or 2 studies conducted. So now the decision maker, they have either to fund another study with larger sample size, or just ask the scientists to conduct meta-analysis. They combine all the included studies with the small sample size. So the final sample size will be a bit higher for meta-analysis. So it's less cheaper as compared of conducting another cohort or cross-sectional study or RCT study. And it considers also variation because you pull data from other countries. So also we have to do meta-analysis if the primary studies could not provide definitive conclusion, either related to because their duration of treatment is not enough or because of the sample size. So in this process, in the meta-analysis, we compute the effect size, the software. So no need for you to understand the equation, all those things. Just you enter the data, I'll show you, we'll do it together now, and then it will compute and calculate the final effect size for you. So what's the benefit? It has higher statistical power, it increases the precision, it provides potential correction of potential bias because you'll exclude some of the studies that it have bias. It's more accurate. Sometimes also we investigate if there is difference in the risk estimate, and we add that to the discussion. So what's the limitation? There is limitation, although it's really good approach to have solid conclusion, but it has limitation because most of the time we are comparing apples with oranges. The systematic review that I will share with you, we'll do meta-analysis for it today. This article, I just thought we better to use this one because it's a bit easier, but we can do the same for other articles. This article, their intervention statin for treatment of depression. I'm sure all of you know statin is for hyperlipidemia, for cholesterol, but in this systematic review, they want to evaluate its effect on depression based on different primary studies. So their study design RCT, and they use placebo. But do you think also here there is kind of apple and oranges? Yes, because they don't compare one statin, let's say simvastatin with placebo. They compare all different statins, although they are under the same category, atorvastatin, simvastatin, and so on and so forth. But they are comparing, they including some studies, they used different duration for treating the depression. Maybe one study, they used statin for 1 month, the other study, 2 weeks, different doses. Different. So sometimes we accept that to have final conclusion, but we prefer to only combine or pull the data of the same outcome. Even here it's the same outcome, but the intervention, it shouldn't have a lot of variation in terms of the intervention. Also, the quality of included studies, it affects the final meta-analysis. That's why you have to pay attention really to the result and to the risk of bias of the included studies. Don't include those with any problem with the validity. Okay. Also, the problem with if you cannot find the negative result, if you don't cover the gray literature, you will see the result here when you do meta-analysis. All the included studies just only saying concluding positive results. So all of them will be in one side. Okay. So publication bias, also another limitation of meta-analysis. It's really difficult to ensure there is no publication bias. But there is tool in meta-analysis. We use funnel plot, or we call it trim and fill method to assess the publication bias. I'll explain it in a minute. So it will tell us if there is publication bias or not. But we cannot use funnel plot if number of studies less than 10. I have seen some systematic review and meta-analysis published with 4 articles, and then they added funnel plot. So to me, they don't understand the concept of funnel plot. I'll explain it later on. They should use equation called fail-safe N. So this equation can be used to assess publication bias for if the included studies less than, let's say, 5 or 7. I haven't used this equation before, but it's easy. It's just only equation. For me, most of the time, because the number of studies, it's more than 7 or 10, I use funnel plot, which is integrated in the ref manager. Let me go to the, okay. So I think I have covered here. So meta-analysis and systematic review. Meta-analysis, if has been done outside the systematic review, can mislead the other scientists or the reader or the decision maker, because the high risk of bias, the risk of bias is not reported, the publication bias, all those things. Okay. Let's go for the effect measure. Now we will go a bit deeper in some statistical terms, but I'll try my best to simplify those terms for you in order to, when we do meta-analysis, you will understand the term. So we have any type of data, it's either dichotomous or continuous. So I think blood pressure, body weight, blood sugar, cardiac enzymes, they are continuous outcomes because there is mean. So we use either the mean difference, which is only X minus Y, intervention minus placebo, or standardized mean difference, which is same equation divided by standard deviation, because here we have to consider the variation. And most of the time, it depends on the outcomes. We have to look at the primary studies. If there is variation in the measurement of the outcomes, it's better to use standardized mean difference. So this is continuous outcomes. But if it's exposure and the outcome, it's either presence or absence, like the preterm death. Do you remember the first example that I mentioned? Or headache, caffeinated coffee, does it cause headache or no? So it's yes or no. Or maybe antibiotics with diarrhea, does antibiotic associated with diarrhea as adverse effect? So here it's not continuous outcome, it's dichotomous. So in this case, we cannot use mean difference, because the included studies usually they report either the odd ratio or risk ratio. So especially odd ratio for case control, and most of the dichotomous or the exposure or the association, they use odd ratio. And here for continuous, mostly we use standardized mean difference. Okay, there is of course other effect measure. So the effect measure either here in dichotomous it's odd ratio, while the effect measure in the continuous, it's standardized mean difference. But there is others, it's not less commonly used, because most of the time it's either observational study or intervention study. So we have time of event. If your outcome is survival data, then you have to use your effect measure is hazard ratio. Ordinal data, you have to use proportional odds ratio. And if it's counts the number of events, rate ratio. So let me just explain what's the difference between odd ratio and relative risk. Can you see my? Can you see? Oops, how to remove this? Okay, now for you to understand what does it mean, the odd ratio or relative risk. So can you imagine this study, they compare between, or they study the association of the diarrhea with the antibiotic. So in the intervention group, how many participants they have? 10. While in placebo group or control group without antibiotics, how many participants? They have 10. Okay, so how many of the intervention group they got diarrhea? 4 out of 10. While 6, there is no diarrhea as adverse event. For control group, placebo, only 1. So what is the risk? The risk, how to calculate the risk, or what's the definition of risk? It's the probability of getting the event from overall. So the risk here, if we want to calculate the risk, it's 4 over 10, because it's the probability of getting the event from overall the sample size. So it's 4 over 10, so the risk here is 0.4. So it ranges between 0 to 1. Does it make sense to you? Because if 0 out of 10 they got diarrhea, 0 divided by 10, it's equal 0. If all of them, 10 divided by 10, they got diarrhea, then the risk will be 10 over 10 will be 1, isn't it? That's why the risk it's range between 0 to 1. So how we calculate the risk ratio? The risk, we have to repeat the same. We have to calculate the risk for the control. So here it's 1 over 10. So the risk is 0.1. So the risk ratio, it's 0.4 over 0.1. So it's 4. The risk ratio here is 4. While for the odd, it's not probability of getting the event, it's probability of occurrence of an event to that it does not occur. So 4 divided 6. So probability of the event to the probability of does not occur, the event does not occur. So 4 divided 6. So it's equals 0.66. While here for the placebo group, it's 1 divided 9, so it's 0.11. So the range of odd, it range between 0 to infinity. Does it make sense to you? Because if it's 0 divided 9, it's 0. But if it's 9, let's say 10 divided 0, if all of them, they got the infinity. Let's say if 8 divided 2, so it's 4. So how we calculate odd ratio? Odd ratio, it's just only the, we have to divide it odd of the first group divided by the odd of the second group, so it's 6. So you can see here, most of the time the odd, it's a bit higher as compared to the risk. And most of the studies that they evaluate the association or correlation of adverse effect of drug, mostly they use odd ratio, not the risk ratio. Some studies they use risk ratio. And remember, this is for dichotomous, okay? While for continuous, we use mean difference or standardized mean difference. So mean difference, it measures the absolute difference between mean of 2 groups, the intervention and placebo, the first intervention and second intervention. So if the included study, they use the similar skill, then it's better to use mean difference. Let's to make it easier for you, let's say we are evaluating intervention for diabetic. So diabetic, it's similar outcomes, but let's say 5 studies, they measure the fasting blood sugar using the AquaCheck home, the home-based small machine that the diabetic patient that they can use it. While five studies, their participant, they evaluate the fasting blood sugar at the hospital using this sophisticated machine. Although both of them, they are measuring the same outcome, but the accuracy of the 2 machines are really not the same. So in this case, to consider that, it's better to use standardized mean difference, not the mean difference. Have you got the meaning? So if there is no variation in the measurement of your outcome, you can use mean difference. If there is variation, it's better to use standardized mean difference. And this is variation between the included studies. Let's move now to the effect size. So what's the effect size? It's index, simply it's index that we use it to compute the effect size, or we combine the effect size of all included studies, and then we average this effect size to get the final effect size. I'll show you in the first plot, I think. So this effect size, what are the factors that it affect, or let's see here, I think. So what do you think? This final effect size will be affected. So usually the software, it will calculate the effect size for each study. So in the primary study, you cannot get this effect size. Only you will get the mean difference. So this is the mean reduction in body mass index, the standard deviation, and sample size for let's say orlistat for medical treatment to reduce body mass index. While this is the surgery, the gastric bypass, this is the reduction in body mass index as -25. This is the standard deviation, and this is the sample size. So the software, it will calculate the effect size for you for each study. And then it will compute all those effect size, and then will average the final effect size. So this final effect size will be affected by many factors, including the sample size. So can you see each study, it has different sample size. So that's why the weightage. So Usually we don't care when we do meta-analysis using Graph Manager. We don't care about this, but it's good to understand the concept. So the weightage of each study, it's based on the sample size. But sometimes if you use random model, I'll explain the difference between fixed model and random model. I know it's a lot today to digest, but at least you will have, I'll introduce the basic things. So later on when you go and see the recording again or check the literature, you'll understand the concept. So the weightage for fixed model, really it will affect the final effect size. But if we use random model, it's not just only the weightage, even the standard deviation, the variation. I'll explain that. But this is the idea how the effect size will be calculated. Okay, so the effect size of the meta-analysis, it could be positive or negative. Does it mean negative? It's negative result or not? So the final effect size, we should interpret the final effect size based on direction towards placebo or towards or favor to placebo or to the intervention, and the size, the magnitude of the effect size, and consistency. If you look here, the result of this study comparing between pharmacotherapeutic and gastric bypass, it's favored to gastric bypass. It's positive. But let's say if it's negative, does it mean it's negative result? No, it's just only, it doesn't matter the negative result here. It's just only, it will tell you that this, the effect size, it's favored to medical therapy rather than gastric bypass. But the magnitude of this effect size here, I will show you the range and the cutoff, how we can interpret the effect size. This is the most important. So here, it doesn't matter because both group, we have two intervention. But if we have just one intervention and then placebo, yes, it will consider negative result. So if placebo here and intervention here, so which means now the intervention is not really very effective in reducing the body mass index. Okay. Also, by the way, those in each effect size, you can see the confidence interval. So the confidence interval, it will give us indication about the prestation of this included study. And there is confidence interval here for the final effect size for the diamond. So this is, you can see the confidence interval here as well. So it's from 0.7 to 1.2. So it has very narrow, which is good, confidence interval. If it's large, it's not good. Okay, so how we can calculate, or the software, the Graph Manager, it calculates the effect size. It uses Z-score to calculate. So when you look, I think better to go here. Yeah. So when it calculates, this is the final total effect size. So this is the magnitude or the value of effect size, it's 1. But the equation that it used to calculate, we call it Z equation. And this is the p-value of the effect size. Is it significant? Yes, it's significant. While those values, this calculation for heterogeneity, we'll come back to this one. So how we can interpret now the final effect size. If the final effect size less than 0.2, we consider that small effect size. If we compare between, let's say, gastric bypass and no intervention, placebo. If the final effect size is 1, so it's really considered because it's more than 0.8, we consider that large effect size. So we can say with high confidence that the gastric bypass, it has larger effect size as compared to placebo or as compared to orlistat in reducing body mass index. So this is the interpretation. Less than 0.2, the value of effect size. We call it small effect size. 0.4 to 0.5, it's moderate effect size. And then if it's more than 0.8, large effect size. So in that study, that meta-analysis comparing between pharmacotherapeutic treatment and gastric bypass, the final effect size was 1. Does it consider small, moderate, or large effect size? What do you think?
If it's 1, it should be large.
Large, yeah, correct. Okay, so for you to understand this effect size, can you imagine now, this is if both, now we are studying the effect size, the difference between the mean of gastric bypass and chemotherapeutic. If the effect size is 0, which means there is no difference between the efficacy of both treatments. So here we cannot advise to use gastric bypass because it has more adverse effect or more severe events as compared to pharmacotherapeutics. But when the effect size is 0.4, you see the difference now between the mean of the intervention and the placebo or other intervention. 0.4 is considered moderate effect size. So we can say the difference between the mean reduction of body mass index between the gastric bypass and then the orlistat, it has moderate effect size. But here, when the effect size is huge, 0.85, it means really there's huge difference between the mean of the reduction of body mass index between the gastric bypass and then the what they call it, the orlistat or pharmacotherapeutic treatment. So here, with really high confidence, we can say yes, it's better for those really obese, let's say their body mass index 45 or more than 40, it's better to go the orlistat. It will not work. In this case, it's better to go if they cannot control their diet and do the exercise. In this case, it's better to go for gastric bypass, because when we pull the data, the final effect size, it's a bit huge. So finally, for the terms, there's 2 terms you have to understand: heterogeneity and then the model that we use it to study effect size. So there's 2 models because remember I told you how we calculate the effect size using Z scoring or Z equation. So in order for the software risk manager to do that, they use either random effect or fixed effect model. So fixed effect, when the assumption that the study is estimating the same quantity, it means there is no, again, variation in the outcomes of the included studies. While random effect, most of the study usually they use random effects because there is variation in the intervention. Let's say for the statin, one study they use one dose, the other study they use other dose. So it's better to go for random effect rather than fixed effect. It's easy to compare between those 2 models in the risk manager. I'll show you in a minute. But is there any concern or does selecting the effect model affect the final result? Yes, it's actually based on the study weight. So the weightage, the software, it will put different weightage if we use effect size model or random effect. Because if we use fixed effect with the assumption that there is no variation in the included studies, in this case, the weightage of each study will be calculated based only on sample size. But if we use random effect, then the weightage of the included studies will be calculated based on 2 criteria: the sample size and then the inverse of variance, which is the standard deviation. So the weightage of each study, usually the risk manager or the software, it calculates this for you. So if you use here the fixed model, the weightage, it's based only on the sample size. So the total here is 18 for the intervention and 19 for patients. So as compared to the study, so which one has higher weightage? The study number 5, the sample size a bit higher, 40 in intervention and 48 patient in the placebo. You see that the weightage, it's a bit higher, 31%, as compared to the first study, because the sample size, it's lower. So this is the way how the weightage, the software, the risk manager, it calculates the weightage. If you are using fixed model. But if you are using random model, then the weightage, not just only based on the sample size, it will consider the standard deviation. So sometimes you will see higher weightage for study with lower sample size because it has less variation. Have you got the concept? I'm not quite sure if I managed to explain. So sometimes if you compare two studies, let's say those two studies, they are almost same. I think this study, it has a bit higher sample size. Let's say this study has lower sample size, but the standard deviation, there is no variation. So the software, if you are using random model, it will consider that to give more weightage for this study, because not just only for sample size, because it has less variation. Okay. So selecting the model, it will also affect on the weightage of the study. This is what I'm trying to explain. And so for fixed model, only the weightage based on the sample size, while in random model, it's based on the weightage of the study and inverse of the variance, which is the standard deviation. So let's go now to the first plot. Okay, what's the time now? Because the last 1 hour, I think we'll have it hands-on. Almost done, I think. The last two concepts, the heterogeneity and first plot. So first plot, I told you when I just started my workshop, I can just have a look to this first plot. We call it first plot. Why? We call it first plot because if you look from this side to this illustration or this graph, it looks like forest. Those are trees. So they call it forest plot. So by looking at this first plot, I can tell you the whole story without even looking at the raw data. So this is the data and this is the statistical part. So the first plot or illustration or meta-analysis, it consists from 3 parts: the data, the included study data, the first plot, and statistical part. So by looking here, I can just tell you it has effect size with 1, which is larger effect size, and it's significant. How I know it's significant? Can you tell me it's how I know it's significant without looking? So if I look here, I can see the p-value is less than 0.0001, which show the total effect size, it's significant. But without, let's say, I'm not looking at this the statistical analysis. By looking at this diamond, I can tell you it's significant. Anyone, any thoughts? How I know? Seems a lot of information. Yeah. Just try, don't worry, just guess. What do you think? How I know it's significant? The effect size, it's sometimes it has large effect size, but it's not significant. But in this case, it's significant. Any idea?
Any idea from the audience?
Maybe because not cross the line.
Yeah, so we call this line, it's the no effect line, and it stands for continuous. Remember, this is standard, this is main difference or standardized main difference. So it means the data is continuous. The type of our data continuous. It's not dichotomous. So the line of no effect, it stands at 0. If any of the included study, the confidence interval, we call this one confidence interval. If it touches this line, then it's not significant. If it does not touch, then it's significant. So all the included studies, I can tell you it has significant effect size favor to gastric bypass as compared to the pharmacological. So what's the confidence interval of this diamond? Those two edges. So it does not cross this line. So in this case, it's significant. I can also tell you the sample size. I can tell you first study, it has larger sample size as compared to the first study by just looking to the square. So which square larger? This study, those two studies, as compared to the first and second study. I can tell you the two studies at here at the bottom, it has larger sample size without looking, without knowing this is 48 or 40, and here it's just only 18 patient and 18 patient for orlistat and 90 patient for gastric bypass. I can tell you there is no variation. The standard deviation here is low for those two studies as compared to the first study by just looking at the confidence interval, because it's not here, it's a bit wider. You see the confidence interval? It's from 0.3 to 1.6. That's why if you look at the standard deviation, it's 20. So can we trust the first study? No, because the confidence interval is a bit large. While this study, it has larger sample size. So they conducted the gastric bypass on 48 patients, and their standard deviation in terms of reduction, it's 1.9. So it has a smaller standard deviation and shorter confidence interval. And I can tell you also the heterogeneity, there is no heterogeneity. Without looking, this is the result of heterogeneity. Usually how we evaluate heterogeneity, it's the next slide. We use the I-square. So the I-square, 0. Without looking here, I can tell you there is no heterogeneity because all the included study, it looks like it appear in one side. It's favored to gastric bypass. So there is no studies here. Sometimes if there is a conflict or discrepancy, you'll find some studies here and there. So sometimes there is kind of heterogeneity. So really, and I can tell you, we use the random, they have used random model and standardized mean difference. For dichotomous, the line of no effect, it will stand at 1. So again, the same concept. If any of those studies, the confidence interval or the diamond, it touch this line, there is no significant. The final effect size is not significant. So if you look at the data, those the included studies. How many studies? 5. So here I can also say, tell you how many studies. It's 5 studies. This is the main. So what data you need to extract for meta-analysis of continuous? Only the mean of intervention and the mean of placebo or second intervention. And then the standard deviation or standard error mean. And don't worry, because some studies, I understand some study, they report standard deviation, other study, they report standard error mean. There is a way in the risk manager to convert from standard deviation to standard error and vice versa. And you need to extract the N number. How many patients for gastric bypass for the first study and how many patients? So only those 3 studies. While for dichotomous, you need the number of events and then N number. Only those data. So it's much more easier. Here you can see the heterogeneity analyzed by I-square. Is it significant? Can you tell me the heterogeneity? So it has low heterogeneity. It's 0. But is it significant? What's the p-value? So this p-value for heterogeneity, it's 0.8. Is it significant?
That's significant.
Non-significant. That's why it has no heterogeneity. So this p-value for the effect size, while this p-value is for the heterogeneity. Okay, I think I have covered all those, how to interpret the forest plot. So from now onward, if you look at any systematic review or meta-analysis, no need to read the result bar or the discussion. Just look at the forest plot, it will tell you everything. Okay, the last term here, the heterogeneity. So sometimes there is heterogeneity among the included study. And this heterogeneity, it could be because random fluctuation, but sometimes this heterogeneity because the systematic error or bias or whatever. So if the heterogeneity is 0 or is low, in this case, better to use which model? Fixed model. And by the way, when you analyze, you can change actually. It's just one click. You can select one time, you can have both results. And when you select different model, you will get different effect size. So you have to look at the I-square. So if it has low heterogeneity, in this case, go for fixed model. If it has higher heterogeneity, high heterogeneity, in this case, better to go for random. But of course, also it's based on the included study. I'm sure you summarize all included studies. So if there is variation, better to use even with low I-square, let's say 20 or 30, better to go for random model. Is there any cutoff to say low heterogeneity, high heterogeneity? Generally speaking, if it's more than 50, and some researchers, they said more than 60%, we consider high heterogeneity. So here in this study 0, or even if it's 10 or 20, it's considered low, it has low heterogeneity among the included studies. And the p-value, if it's non-significant, it confirms that there is no heterogeneity, which means the included studies, they are homogeneous in terms of duration, in terms of intervention, frequency, whatever. Okay, how we measure the heterogeneity? So the effect size, the software, it measure that using Z score. Here it measure the heterogeneity using I square equation. Don't worry about it. There is equation, but the software, it will calculate the I square for you. No need to worry about that. You have to interpret the result. So this heterogeneity, it could be randomly. So if it's random, you cannot control that. But sometimes if it's systematic, in this case, you have to go back to the risk of bias assessment and see what's the source of this systematic error or bias. Is it in analysis? Is it in the publication bias or in the randomization or whatever? And then try to do meta-analysis without this study. Okay, those are a few examples of heterogeneity, like few studies, 2 studies, they just conducted the study on men, and other studies, they use this intervention for women. And this intervention, it affected by hormonal, it has some hormonal association. So of course, it will create, the I square will be a bit high. The method they use, you included both RCT and quasi. That's why when you ask me, is it okay to use both? Yes, you can, but you will get higher I square. So if you have 10 study, 2 of them quasi, it's better to exclude the quasi, be more strict. So your I square here will be less, so more stronger effect size and final conclusion. But if you have less number of included study, it's okay to include all of those. Again, it's during the discussion, you have to discuss all those. The intervention duration, also it will create heterogeneity. There is also other factors like clinical diversity, ethnic issue, socioeconomy. There is statistical analysis. Some of them they use parametric when we ANOVA, others they use, because not normally distributed, they use non-parametric analysis. So it will create kind of heterogeneity for the same outcome, for the same measurement. So how we evaluate, I told you, we will do this one using Graph Manager. How to assess the publication bias. If there is publication bias, just click the function of funnel plot. I will repeat again, for funnel plot, you have to do it if you have 8 or 10 studies. But if you have 3 or 4, you cannot use funnel plot. You have to use fail-safe N equation. It's equation. You cannot do it using Graph Manager. So how you can interpret this funnel plot? So the largest study, it's here at the top with more precision. So most precise studies here at the top of the funnel, while at the bottom, it's the smaller sample size studies with lower precision. But the most important, it looks like symmetrical around the y-axis and x-axis. So around the mean, this is the mean of standard difference, it's symmetric. And then also between the top and the bottom, it's symmetric. So in this case, I can tell you there is no publication bias because based on the funnel plot, there is symmetric distribution of the studies based on sample size, based on standard deviation and standard error mean. But if there is all studies, it's just only here at this direction, there is publication bias. So in this case, I will advise you to go and include the gray literature or try to find other negative results or other articles to be included. But if it's, I told you again, if it's 3 or 4 study, you cannot use the funnel plot. So this is the funnel plot. It's to assess the publication bias. The selection, you have selected only few articles, which is more favored to, let's say, to your intervention. Last concept, sensitivity analysis. When we have to do sensitivity analysis, do you remember? I have mentioned that before we go for the hands-on. We have done with the meta-analysis. When we should do sensitivity analysis, I mentioned that. Let's hear from you now. So funnel plot, it's for publication bias, while sensitivity analysis, it's to test the robustness of the finding. But when we should do that? Come on, any idea? Any thoughts?
If there is some not good data, some like outlier or something.
Do you remember I mentioned that during the risk of bias? So if one, you are right. So if one of the study, it has either high risk of bias in 4 domains, we can test that here. We can include the study, although it has high risk in 4 domain, or if the study, I don't prefer to say it has the issue with the statistical analysis, or it has certain issue with the data, but we can do it here. So simply the sensitivity analysis, it's to run the effect size twice. One with, let's say we have 5 studies, one of them have high risk. So one, it's with all 5 studies, you will get final effect size, let's say 1. And it's significant, and heterogeneity is, let's say, 20. You will exclude one of them. It's just untake. I'll do it now. You untake the study and repeat the meta-analysis with 4 studies. You will get another effect size. Let's say now the final effect size is 0.8. So you will mention, it's good justification for you to include this study with high risk. You will mention, although I have included study by this those author, which has 4 domains high risk, but when we run the sensitivity analysis, the effect size still significant. It reduced from 1 to 0.8, still high effect size. But if you run this sensitivity analysis and then the effect size, it changed from 1 to 0.2 or maybe to 0. In this case, because this study, it has higher sample size, so it will affect. Do you remember the weightage? Each study will have weightage. So now you will say the reviewer, if you include the study, they will tell you it has high risk, and when you did the sensitivity analysis, it changed your final effect size from significant to non-significant. So actually you should exclude the study, because it changed the conclusion. And sometimes the sensitivity analysis, we do it not just only for single study. Let's say you are doing now meta-analysis for 20 studies or 30 studies, and 3 of them, you think that it has issue with risk of bias or has issue with the experimental design, with whatever. So you have to run the sensitivity analysis twice, one with those 3 studies, one without, and report. No need to report everything, all the results, just report the final effect size only. Does it change or it does not? If it does not, then you have to include it, and you have good justification why you include it, because at the end of the day, even though with the high risk, it does not change the final effect size, because your final conclusion of meta-analysis is based on the effect size. Hopefully you got the concept. So last step, I'll not go through. So it's just how to report. Now you have done everything. So you have to attach Prisma checklist, characteristic of studies. When you extract your data, I'll show you in the Risk Manager. You have to summarize finding. You should have risk of bias table, and then data analysis. In terms of figure, you should have Prisma flow chart. You should have forest plot. You should have funnel plot. If more than 8 studies, you have 2 figures actually for risk of bias. I'll show you. And then if you want to publish certain journal, you have to follow the guideline. I think the good systematic review, it should include all those. So the research question should follow. So this is to wrap up to the whole workshop. The research question should be based on PCOS. The searching should cover different databases. Selection of studies should be reliable based on inclusion and exclusion criteria, and should be done by 2. You should assess the risk of bias using tools. You should extract. You should have a reliable way of extracting your data, and it should be done by 2, because sometimes by mistake you extract wrong data. So can you imagine if 2 are doing the same step, they will get different numbers. Then when they discuss, they will see who extracted the data wrongly or mistake. Then for meta-analysis, it should be the best systematic review if it includes meta-analysis. If in this meta-analysis, they assess the heterogeneity, they assess the publication bias by funnel plot, and they assess the sensitivity analysis for high risk of bias. And also if they assess the certainty or quality of the outcome using grade. But some studies, they don't add this one. It's not essential, but it would be better. And then if this systematic review has clinical implication, because at the end of the day, if you run systematic review and meta-analysis and it doesn't have any clinical implication, so what's the point? So it would be great if it has, you will advise the scientists, and you should update this systematic review. So what are the software that we have it? Usually we have Risk Manager, it's free of charge. The one that you just install it will do it now. But we have also some, you can see some forest plot, it looks like a bit different in terms of formatting because they use other tools, other software called CMA, Comprehensive Meta-Analysis. I use also this software, but it's subscribed, you have to pay. I think it's £700. But you can install it as trial for 10 days. Also, there is another tool by a founder from Australia. We call it MetaXL. You can install it and it attach as add-on in Excel. Do you know that EndNote, when you install it, it attach as add-on in Word file. So MetaXL, it appears as add-on, add-ins in Excel file, but it's a bit tough to deal with this software, this platform, because you have to know the coding. It's coding based, so you have to know. So usually for me, I prefer Risk Manager, which will do it now. So now the hands-on, we will open the Risk Manager. Risk Manager, it's not just only for doing data analysis, it's for writing the protocol. So if you want to publish under Cochrane, you can draft the whole protocol and the whole review using Risk Manager. But for me here, very useful links for how to use Risk Manager, but we'll do it now. But for me, I use the Risk Manager for 3 things. To create the Prisma flowchart, but again, Prisma flowchart, you can do it manually. You can just amend the one that I email you. I use it to assess the risk of bias. I use it to do meta-analysis. But drafting the whole protocol, usually I use the Word file. So those are some of the reference. So that's it. I think we'll spend now 1 more hour for the hands-on. So what I want, before we go, do you have any question before I go for the software? I will receive.
I have a question from Dr. Putu.
Can you, the others, I will receive your question now. Can you just open this review manager? So now it's in your desktop. Do nothing, just open the software. It will, there is new one.
Excuse me, we have question from Dr. Maftuha.
Yes, sure.
Okay, thank you, Dr. Nurina. Excuse me, Prof. Muhammad. I'm sorry, I'm still confused about the sensitivity analysis. So if we exclude 1 or 2 studies and the result is changes affecting our conclusion, so it is still acceptable for meta-analysis, and we have to show this in our manuscript. I'm sorry, it's just right that my perception.
Yeah, so if the effect size really changed, in this case, you should exclude the study, the one with high risk. So in the final manuscript, you have to exclude it from the meta-analysis with justification saying it has high risk in 4 domains or 3 domains. And when we run the sensitivity analysis, it changed the effect size. But if the final effect size does not really change, it's still significant, it's just reduced from 1 to 0.9. In this case, include it in the meta-analysis with justification that the final effect size does not really change. Is that clear? So there's 2 scenarios. Okay.
Yes.
Yeah, please.
So if we check some variables, so in only one variables that that study it's not good, not a high risk to bias. So if we exclude all the studies from all variables, or only this variable.
No, usually for sensitivity analysis, we do it only for those studies with high risk in not just only 1 domain, in 5 domains out of 6. So let's say if you have 20 studies, of course, some of the studies will have unclear in 2 domains or high risk in 3 domains. So no need to do sensitivity analysis. Only this step should be needed. You should do it if one or two study or three study have high risk in 5 out of 6 or 4 out of 6. And in addition to that, you don't trust the data, the result of this included. And you are expert when you check the finding, when you look at their way how they do the statistical analysis, you will say there is question mark, there is outliers, there is they have removed outliers. So in this case, you have concern about this study. It will affect your final effect size. So it's better to do sensitivity only for that study, not for all.
Okay. Thank you, Prof. Muhammad. It's clear. Yeah.
Any other questions?
Let's see at the chat box. Oh, we still have no question at the chat box. So Prof. Muhammad, I just want to confirm once more about the risk of bias. So we can conclude that is it okay if we have some studies with 3 of 6 high risk of bias? But if it is 4, so and we cannot exclude we decide not to exclude it, so later we can do sensitivity analysis.
Correct. If you look at even the Cochrane, I'm sure, but I'm not quite sure which page, you will find some of the studies. Yes, here. Let me just close. Can you see this? Sometimes we look just to the figure. So the figure where it's appeared. Because the one published under Cochrane, it has, this is the meta-analysis.
High risk, yeah.
This is the grade, yeah, here. Let me just reduce it. You will find some articles published under Cochrane with 3 domain high risk and still acceptable. So this is the grade for the outcomes. Yeah, so this is, so you can see those are the studies. So the first study, out of 6 domains, they have just only 1 domain, which is selectivity reporting. It's uncertain, not clear. But you can see the study by Delphin 1986, how many high risk domain? 3.
Yeah.
But it's still acceptable. And here 4, in subblock 2015, it's 4. But at the end of the day, to me, what types of domain it has high risk? So let's say in both randomization, blinding, so you cannot really trust this study. It's better to perform sensitivity analysis for the study. The other factor you have to consider, that when you read the result, do you trust you are expert in this area? Do you think the finding it's good to be pooled among other studies or not? Not just only based on this. So if you don't trust that, it's better to run the selectivity, sensitivity analysis. So you can see here 4 and 1, it's unclear, only 2 domain, it has high risk. And this is published under Cochrane and still acceptable. So actually for risk of bias, there is 2 graphs, one based on studies and the other graph, it's based on overall. It summarizes this graph. So here it's color based, based on each domain. So you can see the random sequence, it shows there is no high risk. But most of the high risk, it's under which domain? Blinding of participant. It seems few studies, it has high risk of blinding, which means the participant during performance, sorry. So this is performance domain. So it means the assessor, they know these samples, it comes from the intervention or from the placebo. That's why you can see higher. So this illustration, we will do that now. It will give you overall estimation for different domain, and you need to add both figures actually. And this one, it's based on studies. So all those include the studies for the 6 domain. So hopefully now it's clear. So when they run meta-analysis, let's say for this Delphin, subblock 2005, they should run meta-analysis twice if it's included. I'm not quite sure if those researchers, they included to the meta-analysis or not. So this is the meta-analysis. You have to look at the included studies. Yeah, it's here. So they have included for this outcome. Of course, sometimes you have to do different meta-analysis based on how many outcomes. So each outcome, they use different, what they call it, different meta-analysis. So here, how many studies? They included 1, 2, 3, 4, 5, 6. 6. And they include this one. And the final effect size, because this is sub-analysis, so I can say here it's 49. So it's significant. Actually, you can look to the diamond here, it's significant. And heterogeneity, but it's a bit high. Can you see? It's a bit, I will enlarge it a bit. The I-square, it's 99. And p-value, you can see it's significant. While the effect size is 49, and it's significant because it does not cross the line of no effect, and it has huge effect size, but because the high heterogeneity, I think it's better here to use, let me just check what's model. They use random model, which is okay because the high heterogeneity, and they use mean difference. If I am here reviewer, I will advise them to use standardized mean difference. And then I will ask them to do sensitivity analysis, which means they have to report this effect size with the study and without, because the study, it seems, and the weightage, it's 57. It has a high weightage. So it's better to do it twice. Actually, they didn't report all the details here. I can see some missing data, so no, it's here. So this is the sample size, I think. This is the average. I have to have a look. And this is the favor to the other group. This is vitamin D, I think. So this is vitamin D, while this is the placebo here. Okay, any other question before we move to the hands-on? If you have any other question, also after the hands-on, I'll stay for half an hour. Don't worry, you can ask me or 15 minutes, 20 minutes, even after we close the session, feel free to ask me. I am okay for today to have it after the class. While the rest, if you want to leave, it's okay, feel free to do that. So now, can you just follow my procedure or just observe me? It's based on your preference. So when you open the Ref Manager software, it will appear a new window like this. So now just click Create New Review, because we don't have review to open. And if you have to read the handbook, I attach, by the way, if you look at my what they call it, materials near each software, even for CMA, I include the handbook for all all softwares. Okay, so just click Create. I will go a bit slowly. Just create new review. Have you done that? If you want me to repeat any step, just unmute and ask me to repeat. So then, to this wizard, just click Next. So this is type. Do you remember I explained there's different types of review: intervention review, diagnostic, observational, methodological. Others you can also add here, prognostic or whatever. So let's say now I will apply the statin on this one. So it's intervention. Clear? So let's say your systematic review, it's intervention. It's not exposure or diagnostic. Then click Next. So here, let's for statin. What's our intervention? It's statins. You can do yours, whatever your intervention. What's the health problem? Depression. Okay. And then click Next. So now, at which stage we are? Protocol or full review? And this is important step, because if you click protocol, you cannot do data analysis. You cannot do meta-analysis. It should be under review. So let's start first with protocol because I want to show you something, and later on we can convert between protocol to review, full review. So if you want to publish your protocol under Cochrane, you have to select protocol. But if you want to do only meta-analysis or ROP, then just go for full review. To show you the protocol, just click finish. There's no next here. Click finish. All of you got the same? I'll wait for you.
Yes, Prof.
Okay, so you can see here, this is the menu panel here, or window at the top. This window, we call it the content window. And here, this is the layout. Can you see that my mouse? I'm not quite sure if you are able to see my mouse.
Yes.
Yes, yes.
So this one, we call it layout. This is the content of the window, and this is the menu. And here there is abbreviation. Really, I like Review Manager because it's friendly use. We can use it really. It looks like Word. Okay, can you see P here? So P stands for protocol. So if you are trying to do data analysis while your Review Manager under P, you will not be able to do that. You have to convert P protocol to review. And also, have you noticed some of the sections of this protocol, it's in black, others it's not active, like abstract. So for protocol, usually we don't have abstract, we have just only background. We don't have discussion, we don't have data analysis. Can you see the data analysis? It's not active. So mostly for protocol, we have background, objectives, and methods. So those are activated. If you want to access any part of here, just click here. So if I want to start with writing the title, as I told you, for myself, I don't use this platform to draft the whole protocol because I publish in other journal, not the Cochrane. But I will explain that if any one of you are interested. For me, I just use it for meta-analysis and risk of bias and other tools. Just click here. So when you click here, it will go to the same place. So now if I click that title, let me just check. So if I click abstract, so there is little k here. If in the abstract, it's structure abstract. So it consists, so now it goes here in the content and to the abstract. I want to start with the background of the abstract. Actually, you can write here, whatever. It's simple like Word. Even you can copy and paste. If you have any text in the Word, just copy this statement and here paste. Whatever. You can enter, you can insert symbol like Word. So let's say I want to insert PETA or whatever, it's the same. I want to insert link, same. If you have link or if you have even reference. Okay. So it's simple as that. If I want first to, let's say I want to add authors. So just add author. So this is the format for you. And click here. You can have right click, edit the author. So you can add the first name, surname, position, email, department, in order for the software to create the affiliation for you. So no need to type the affiliation. Just complete those, especially those with the asterisk. It's compulsory to complete those. City is not important, so those not important, it's okay. So once you complete all those, and then you just save, it will appear here. So let's start by the way, also the other simple way, you just click here, highlight this one, and then just write, or no, it should, so you should edit first. You can delete the author, you can move down. So this author, you want to move it to be number 2, but we have to edit first. Let's say Adam Smith, but I think it needs the whole Smith. Needs, I think, all the information, which I don't prefer now. to have it. So it appears, it accepts. So you see, this is the name. The second name, let's edit the author. So let's say Brown, whatever, Brown. Whatever or whatever. So the second, now you want to move this one up the first as first author. So just right click and do the adjustment, whatever. If you added the affiliation, it will appear here, all the affiliation. And here it's the title. You can amend the title. Of course, now I cannot edit the abstract. I can add it, but I think it's not active. Let me just try. Yeah, but I don't think it will be captured because it's not active in this case. But you cannot, apparently you cannot do data analysis. So if you want to expand any section in the layout, just click this little K. Because under background, there is description of condition, description of intervention. So this is the format. That's why when you look at the protocol of the systematic review under Cochrane, it's very long article in even systematic review. The objective, the methods, so the methods, it contains the criteria. So even under criteria, types of studies, so you have to complete the data here. So you have to look at the other article, types of participant, types, so all the information. Okay, but of course we cannot do data analysis here at this protocol, but we can add studies. So when you add studies, you can add it under reference. Let me just close this. So studies and references, you can add it here. By the way, you can expand this or expand this based on your preference, the same also here. So before I add, so there is no table, you cannot create any table now before we add the studies. But before that, I want to convert this one. Let's say I'm not interested in protocol. I want to convert that to full review. How I can do that? Just go to this little b with right click, go to the properties. Can you do that? Can I get water? Can you do that, all of you? So click properties.
Sorry, no.
Yeah, it's just
How to
only
click properties.
Yeah, here in this little p, not this one at the top. No, this one. Click properties. Okay. And then after properties, you can change. If you forgot to change at the beginning, do you remember when I created this protocol, this review, I selected protocol. You can actually now, even if you forgot to do that, just change from protocol to full review. Of course, if you are a member, you will get review group name, and there is review number will be provided by the group. And actually this platform, it's synchronized. That's why I got one question before the prayer. Do I select the standardized or non-Cochrane? So if you are a member, it's better to go for standardized because this platform is synchronized with the whole group. So once you create, actually the group number will be detected here, and then you will get review number based on your group. All those information will be completed. But since we are doing what they call it, the non-Cochrane standardized platform, so you will not be able. This unique ID, it's automated created, will be automatically created. Okay, so just go for full review and then just click OK. Have you seen the P change to R? So in the future, if you open and forgot, let's say when you create a new one, and then you just click finish instead of next, you click finish, it will appear as protocol. You cannot do meta-analysis or risk of bias unless you change this one from protocol to review. And now if you, can you see the abstract, all the, it become active. Even you can now do the data analysis. Clear? You can also, by the way, you can do track changes. There is track changes. Let's say you are writing, and because this is synchronized, and then you are you want to let's say starting. So it appears, you see, as track changes. Same function like Word. If I delete this one now, because I activate the track changes, it appears as track changes, because I want this protocol to be evaluated by, so I am a reviewer, or I am supervisor, or whatever, or collaborator. So I add my review as track changes. So actually, if you are working on Word, it's a bit similar with more function. It's really friendly user platforms. Okay, the first step before we go for, so writing the protocol, it's just as I told you, copy and paste, or just typing. There is no issue with that. But let's add references before we do risk of bias, characteristic, data analysis, all those things. So in order to add studies, you should add it under here, studies and references. So if you click this little key, you will get reference to studies and other references. So it's the reference, it's arranged under included studies, excluded studies, studies awaiting classification, ongoing studies. And there is other reference, it's additional reference, other published version, and then classification pending reference. Of course, the meta-analysis or systematic review, it includes included studies, but also you need the excluded studies, because you have to cite them, especially those studies that it reached the full text stage, and you exclude it because of any reason. So you should mention in your methodology, I have excluded 5 studies because they are review article, or they are reports, or they are not relevant. And then you have to cite it. So how you can cite it? It should be, you should first add those studies under exclude studies. And you can move the studies from included to exclude. If I click now under included, you see, you can add whatever studies under included. And if I want to add excluded here, studies awaiting classification, if you just search for studies and now you insert those studies and still you are not sure. You are not sure if you are going to add it to included or excluded. So in this case, don't add it to included. Just add those studies under awaiting classification. What about the other reference? You need reference for your background, it's not just, so the reference, the citation in your systematic review, it's not just only included or excluded study. Of course, for your systematic review, we'll start with background introduction, with some literature. In the discussion, you will have some reference. For your methodology, you will cite the PRISMA checklist, PRISMA statement. Do you remember? If you, let's say you mentioned in your methodology, I have this systematic review follow the PRISMA guideline, and then you have to add the citation. So this citation or this reference, it's not part of included, it's not part of excluded, it's part of additional reference, the reference that you want to use it to for your writing. Clear? So there's different way of adding those studies, either from EndNote or PubMed. So you save it. Do you remember for PubMed? Let's say now all of your PubMed included study, you save it as BMID. So there is 4 format. I think if you add, let me just show you the format. So import, if you want to add from PubMed or from what they call it, EndNote, go to import and reference, file, import, reference. I repeat, go to file. You want to import now some of included study. Go to the references. So then click next. You have to get, unfortunately, I don't have, let's save some file from PubMed, or maybe I have some in the, it should have certain format, otherwise it won't accept. Let's try, otherwise I will get some from the PubMed. It does not accept. Okay, let's Are you interested? Because also the other way we can add manually also. Usually for me I add manually, but let's go for PubMed. Let's search just for COVID, whatever studies, COVID-19. So let's select just 3 studies or 4 studies. I don't want to select few studies. So you have to save it as, so just select a study, 3 studies. Remember, there's different format, either PubMed, BMID. So I think it accepts BMID and PubMed. Let's save it as BMID and then create file. So it's in my download. Okay, now let's go back to the reference manager, ref manager. Where is it? I have too many windows here. Okay, so back. So next, let's get the file. So it's in the my download. There's my download. Stop. Oh, I go back. Cancel. If you have file from EndNote, also you can try that one as well. So desktop, where is download? Yes, it's here. So this is the file, cross COVID search result. Is it, this is the one that we save or this one? I'm not sure. This is, sorry, BMID. It's in BMID format. So, and then just click open. So you see how it appears? Only how many studies you can see here? How many studies?
3.
3. And then click next. So what are the formats? So only Ref Manager, it accepts those 4 different formats. Ref Manager format, the PubMed format, the RIS, which is from EndNote or Vancouver. So if you have reference in EndNote and you want to add it to the Ref Manager, try to save it as Vancouver format or RIS. So I save it as BMID. So I don't think it will accept. Let's select this one. See, so it does not accept because I save it as, I should select either RIS or Ref Manager. Let's go back. Sorry for that. Back. Okay. Let's go back to the here. So the selected save as. So it's PubMed. Can you remind me? I forgot what are the format that it accepts. PubMed, it's one of those.
I think
BMID.
The first is BMID cannot accept it in the RefMed.
Yeah. So let's try now this one, this format. But sometimes for me, I use from EndNote. I save my EndNote as Vancouver format or RIS, and then I use it. Okay, let's now try this format next. So this is the PubMed. Open. And then next. Yeah. So this is PubMed. So one of the format, it's PubMed. So when you click next, it accepts. So now you want to add those studies to included or excluded or waiting classification. So I will just add it to waiting for classification. Let's say I want to screen it first and then click next. So you see how many studies I got here? 3, and then just finish. If I go now to the studies, you see a little key appear here. So it tells me 3 reference imported. Little key here. If I click here, I can see 3 different studies under awaiting classification. If I click here, those are the 3 studies. There's a problem here with the citation, but I think those are the 3 studies. So this is how to do it automatically from the database. Just go to File, Import, and then Reference. And you should ensure that you save the file. You can import even 100 articles or more. It doesn't matter. The most important, it should be your file in those 4 formats: PubMed, Ref Manager format, RIS, and the 4th one I forgot. what are usually for Vancouver? Yeah, Vancouver. Yeah, so it's the same for me. How I do it? So can you all? Because I will use this data to do meta-analysis. Can you go to the material that I provide? So as I told you, each software, it has its own guideline and some what they call it, the handbook, some resources. Can you open this raw data for meta-analysis? So I extracted this data from this manuscript, from the statin manuscript. Let me just check. Let's compare. Let's see if you are still with me or so. Let's go. So this study, it's for the efficacy of statin, different statin for depression. They started with 67. They recorded, they after removing duplicate, no duplicate, 67. So actually the first comments here, why they didn't report number of hits for each databases. What about gray literature? So this is not really with high quality systematic review and meta-analysis. Then they have excluded 56. Then they retrieved 11 articles for full text. They excluded 8 because, and they wrote the reason, which is good. 1, because ongoing clinical trials. 1, there is no placebo, so they wrote the reason, and only they end up with 3. So let's go to the characteristic. So those are the 3. So from where I got the data, from here, from this table. So this study, I just got the sample size. So their outcome is HDRS baseline. So this is scoring of depression. So their outcome, do you remember? They want to evaluate the efficacy of statin against depression as compared to placebo. And how they measure the outcome, they use this, those familiar with depression, they use this scoring system, HDRS. So as baseline before statin and after statin. So it's baseline and then after follow-up. And this is the value. So if you look at my data, can you tell me why? Is it same? I will put them together. Can you tell me, is it same or different? So I'll minimize this one. Yeah. Oops, sorry. So the first study, oops, and this one also. Or maybe one near each other. I think, okay. Maybe if you are opening one of them and just look at the my figure. So the first study conducted 2013 for the placebo, for the intervention, they used lovastatin. What's the sample size? 34 placebo. So I wrote here, can you look at my data? Come on. I wrote the first study for intervention for statin only 30 and for placebo 31. Can you tell me why? Why I didn't? Actually, I extracted those data from the meta-analysis. Why is 30 and 31? While in the article, if you look at the article, as I told you, it's 34 based on the article, the sample size 34. And this is the baseline.
Drop out.
Yeah, so remember how many dropout I have in the first study? 4. So you should not, when you do meta-analysis, you cannot include, so let's say the primary study, they reported that they started their sample size 34, and then they have 4 dropout. Do you think, are you going to score this article for which domain? The attriation. Do you remember the attriation? Are you going to score it high risk or low risk? Because the dropout 4 out 34, and here 34, it's 3. It's more than 5%. Yeah,
how
so,
many percentage that we can?
Yeah, so it should be high risk.
As high risk.
Yeah, let's see later on in the how they evaluate. Perhaps you can go through because of time concern. So
more than 10%.
Yeah. So after you remove the dropout, when you do meta-analysis, you have, because this main, it's not for 34 patients. It's only for the final patient, which is 31. That's why you see simple mistake, it will really affect the final effect size. So be careful. You should consult even an expert when you do meta-analysis. It's simple. I will do it now within 5 minutes, the whole meta-analysis. But the systematic review, it takes 1 year. Because simple mistake like this one, you didn't consider the dropout, it will affect. And the simple size, it affects the weightage of the study. So instead of 34, you should put it 30. And here, instead of 34, I put it 31 because there is 3 dropout. What about the main? Before at the baseline, 28.9 and 27.6. So it's the same. I assume it's the same. Where is it? 16.3 and 20.4. Yeah. Sorry, this is, let me just check. Gender dropout. Yeah. Yeah, this is the result. 16. So 16 and 20.4. Let me just go back.
Yeah, it's the same.
Same. Okay. And then the second study, there is no dropout, so I put 30-30. What about the standard deviation? It's here. It's not reported. From where I got it? Actually, I got it from I think from here. I don't know. I think from the first plot itself. But you should get at least the standard, the n, the mean, and then the standard deviation. If you have standard error mean, I'll show you how to convert standard error to standard deviation. So now what I'm trying to do in this study, I will just add studies under included study. I'll add it manually. So I show you how to add it to import from database. I will add those 3 studies because we'll do meta-analysis and we will do risk of bias and characteristic for included study. So what you should do, just copy the study, only this name. Copy the first 3 study and click the included and under included, not excluded. Just add study. Also the other way, right click here and add study. So either under included, right click, add study, or under included, just add included study. So it gives you example how you can do it manually. There is no comma between the surname and the year. So I just added name, surname, and no need to add it out, whatever. Just the name of the first author, the surname, and the year. You can click finish or just click next. So is it published or not unpublished data? It doesn't matter for me here. Perhaps later on you can go through. The year already captured automatically for you, so you have to do nothing. Next. If you want to add identifier or any comments, also you can add. If not, now what's the next step? You want to do nothing, so it will close, or add a reference for the new study, or add another study. So this reference, the one that I added, it's considered a study. It's not a reference. Sometimes one study, it has 2 references. Let's say they have conducted 2 clinical trials for the same, or let's say they published 2 articles, 2 reference for the same clinical trial. So you can have 2 reference. So what I should click? Add another study. So it's not reference, I will add another study. So can you click add another study? Because I want to add another, and then click continue. Because I want to add, and then go here, copy and paste this study. So when you click continue, you will add the study. Let's say now I finish. I will not go next, and then add another study. Finish to see if all those 2 studies added under included or not. Just click included study. First, the little key here, you can see the 2 studies that I have added. And under each study, if you want to add another reference, you can add. Also here, if you go under clinical, under included study, you can see, can you see the 2 included studies? Let's say now I want to add 3rd study, or after 2 days, 1 month, I want to add more study. Again, it's the same step. You have to click include study, either from here, add study, or right click on included and add study. Let's add the third study. So I'll just click this one and add it here. Remember, there is no comma here. And then just click finish. How many studies so far I have added? 3 studies, okay? So let's assume we have just only 3 studies. I will just replicate this systematic review to see if we'll be able to have at the end of the day, we'll have the same meta-analysis, the same forest plot, same risk of bias, same forest plot. This is the forest plot or not. They have done, this is their grading. This is the meta-analysis, the forest plot. Based on this forest plot, can you tell me, let's, before I carry on, I want one of you just summarize this. I know we are running out of time, so, but it's okay. Can anyone, I'll enlarge it a bit. Can anyone summarize this one to tell us what's the final conclusion without reading the article? Oops.
Anyone, please? Anybody, please? Dr. Tutu, probably.
Don't worry, even if you are not quite sure, it's okay, because I just introduced how you can interpret the forest plot.
Or Dr. Yuli.
Dr. Yuri?
Okay, I will try, Dr. Nurina and Professor Mohammed. I think this meta-analysis analyzed 3 studies, and all of the 3 studies is the effect is a significant, have significant effect of the effect is significant, and the overall effect is also significant.
Is it high effect size, moderate, or low?
I don't know. I think it's.
Can you read the effect size for us? What's the effect size?
This effect size is significant. So this is the height, maybe.
Yeah. Can you read the value of the effect size? I want to see.
The effect size is from Z 4.53, and the significance is less than 0.
Yeah, but the value of the effect size, it's here. So this Z score. This just only the equation to calculate if it's significant or not. So usually the effect size, we don't look at the value of Z. We look at this value here, or we look at the diamond, the main of the diamond, it's here. So this is 0.5, so it's here. So the value of effect size 0.73. So 0.73 consider as moderate. Do you remember I told you 0.2 and less, it's low. Moderate between 0.4 to 0.6, I can say. Above 0. Or even to 0.7. Above 0.8 consider as large effect size. So what do you think about 0.73?
Moderate to high?
Let's say maybe it's near high to moderate, yeah, because it's less than 0.8. Yeah, that's why I told you it doesn't matter the minus here. It does not mean negative result. It's just only when they design the first plot, they put statin at the left side, which usually the first plot at the left side, it's minus. If they put statin at this side, it will be positive. So here, it's just only, it means that the effect size favor to statin. It's not favor to placebo. So when they report the effect size, they will not mention it's minus 0.73. They will mention it's 0.73 with confidence interval. So the 95% confidence interval is between 1 to 1.05 to 0.4. So it does not cross the 0. So it's from here, from 0.4, I can say, up to 1 plus. This is the confidence interval. And then after I look at the effect size value with the confidence, so what are the data that you want to report in the result. You have to mention the effect size, and you have to mention, is it large or moderate or low effect size? You have to report the confidence interval. Is it significant? So if it's significant, you have to look to p-value. Here it's significant. If it's non-significant, it will cross this one, and then the confidence interval, it will contain in the middle 0. So 0, it will be in the middle part of the confidence interval. You are right, it's 3 studies, as you mentioned. What model they used?
Random.
Random, and standardized mean difference. Random because I-square, so I-square, can you see I-square here?
0.
0. Actually, it has low heterogeneity, even it's not significant. Usually heterogeneity, it's significant if there is high heterogeneity. So significant, it means the included studies, it has high heterogeneity. So we
How many percentage considered high for the
I told you that the cutoff value usually 50 or 60. It depends on the journals. Some studies, they are saying 50 or 40 above. It's considered high. 40 to 50, moderate heterogeneity. Above 60, it's high heterogeneity. So the study, vitamin D, it was 99.
Yeah. Can we say from this forest plot that the effect size is moderate to high? It's not high because you can see the confidence interval here is quite wide.
Because the value itself, it's 0.73, it's less than 0.8, so it's considered a bit moderate, I can say. But actually, it's significant. If you look at the p-value, it's significant, and then the confidence interval, not as compared to individual study, is not that high. Yes, I know the range from 1 to 0.4, but still acceptable.
Okay, thank you.
So what I'm trying to say, why I asked, because if you understand now how to interpret the first plot, I can say you really understand the meta-analysis. So you have to look at this value, we call it effect size, the confidence interval, and then look at the diamond. If it crossed, look the p-value. Z-score, forgot about it. Usually we don't report the Z-score, score, because this is just only calculation equation. It's like t-test. Any one of you have done t-test? So do we need to, usually we report that t-test, the t-value? No, we calculate the t-value in order to see the, to see the p-value. So we get the t-value, we go to the table. For those that are doing it manually, if you remember, nowadays we use SPSS. So we calculate, there is equation or formula to calculate the t-value, and then based on this t-value, we look at the probability table. If you remember probability table, if it's less than 0.05 or more, so it's the same. Z-score, it will give you value, but we don't care about it. We care about the effect size and the p-value. So this value is to calculate the p-value. So here it's significant. The good effect size, if it's more than 0.8 and at the same time, it's significant. And the other thing that we have to look is the I-square. Is there any heterogeneity? Because even sometimes if there is high effect size but higher heterogeneity, we can say there is variation among the studies. So actually, I am just wondering why they use random model while the I-square is 0. Do you have answer for that? Why they don't use a fixed model? Why they don't use mean difference instead of standardized mean difference?
Because variable types of setting, or
yes. So the intervention itself, it's not just single statin, it's not the duration of action, many things. Can you see that the weightage here? I want to tell you that I'll show you now the difference between random and fixed model. So which one has higher weightage? Study 1 and study 2. So which one has higher sample size? This is 30, 31. So it's almost same, yeah. Here it has less sample size. What about the total? I told you meta-analysis, it increased the power because the sample size. So instead of each sample size 30, only 30, here we have final effect size for 81 and 83, 83 placebo and 82. So of course, the final conclusion, it's better as compared when we have conclusion based only on 22. Okay, so anyway, let's go back to the ref manager. Sorry, this is the end note.
Prof.
Yes.
Excuse me, Prof. I'm still confused. Why? When can we put the statin in the left? I mean the minus value, or vice versa?
It doesn't matter. Actually, if I were in place of this researcher, I will put statin here and placebo here, because some they misinterpret the minus here. They will think it's negative, but actually it's not negative. This is direction. It means the effect size towards or favor to statin. So you can do that. Now I'll show you when we do meta-analysis. You can select statin here, or let's say for, do you remember this one for, do you remember the one for gastric bypass?
Yeah.
Yeah. So
with early start.
Actually, yeah, here, this one. I have first plot for odd ratio, but it has the same principle. So this is gastric bypass here. And this is the pharmacotherapeutic drug. It's negative. So the negative, it does not mean negative. It means just only the effect size favor to the this one. For me, most of the time, I prefer to have placebo here. If in this case, we have two intervention. But let's say if you have placebo, I prefer to have treatment at the right side, and then the what they call it, the placebo at this side. Because some non-expert, when they look at the data, when they see the minus, they think it's negative, but then the minus, it doesn't mean negative. It's just show the direction. Okay.
Thank you, Prof.
You can do that actually. I'll show you now. Let's go. Sorry. Back to the ref manager. So now I added the studies. Before I do data analysis, can I show you now the risk of bias characteristic? So all of you, since we have studies, and now you can click here. Can you go to tables? Click this little key. So now you have characteristic of study, you have summary finding, you have whatever. So can you click this characteristic? So it will show you. Do you remember what are the studies that we added? Genzida, 2013. So already the software itself, it created two tables for you. One as characteristic, the other one risk of bias. So no need for you to create the table. So here you can add, let's say the first study, it's RCT, and then I'm still under, let me remove this one. The track changes. RCT, and then what's the participants, adult, whatever. You have to add adult patient with depression, whatever. So you have to add all the details. Intervention, statins or simvastatin. What's the outcome? Can you tell me? I forgot what's the score. SDHR. Can anyone just read it from the PDF file? What's the score they use it to score the depression?
HDRS.
HDRS. Okay, you can have more than outcomes. Actually, you can add other here. You just go to the properties here. You can add 3 additional heading. Let's say secondary outcome. Just define your secondary outcome. Okay, you can add other. So it will appear now as additional. You see another. So this is the characteristic. So when you extract from the methodology. Now the first study, let's score the characteristic. I'm not interested, I just show you how to do it. But for me, usually I use Risk Manager to do risk of bias. So where is the I explained the 6 domain. Random sequence generation, the randomization during the selection, if the participant will go to the placebo or intervention, then allocation concealment, and then blinding of participant and personal during the performance, and blinding during the assessment, and complete outcome, the attrition bias, we call it attrition, the dropout or withdraw, and then selectivity reporting, and then other bias. Let's just do randomly. I don't have time now to follow exactly what I want, just to show you how to do it in order to get the two figure, the one that I show you. So just select, let's say, low risk, high risk, randomly. Perhaps later on you can do it same as they have done. Unclear. So remember, for ROP, it has only 3 levels of scoring, either low risk, high risk, unclear when there is no information. And all those included study, they are RCT. Of course, you have to add judgment support, justification for judgment. So if it's low risk, you have to mention they use computerized whatever, okay? Computerized randomization method. If it's high risk or unclear, you have to mention they didn't mention. Or let's say here, high risk, you have to mention they use transparent envelope, or the participants, they are aware about the allocation. So you have to add all those. But again, I don't have time. I'll just do it manually in order, and I should do it for the 3 study in order to get the final figures. Can you do it with me? So I finished the first study. Then you have to go to the second study, just go down. So again, there is 2 table for Google 2015. This is characteristic. I'll not do it. I'll just do risk of bias because I want to show you the figures. Just randomly, low risk, high risk, high risk. Of course, you have to do it after you read the full text, and you have to score it based on judgment. Low risk, and unclear, low risk, and then go to the third. And if you have 20 study, you have to do it for the 20 studies. And this one, are you following me? Or I am a bit too fast?
Actually, it's difficult for us to do it hands-on while need to keep focus on the screen.
I see.
I mean,
by the way, this session, it's recorded, isn't it?
Yeah.
So you will circulate the recording for the participants in case if they want to do it again. If they have any issue, they will just watch that video. So now I have done for the 3 studies, okay? Of course, I can, do you remember I have included some studies under studies awaiting. I cannot do risk of bias for those studies, but I can do it for excluded studies. If I have certain studies under excluded, if I want to, before I exclude them, I don't think, only for included studies, sorry for that. Okay, so I have done that. Before I go to the figures, I want to show you what else. The other types of tables. Let's say I want to add additional table. Let's say I have in the methodology or in the introduction or discussion where you want to add table, additional table here. Let's say whatever, grouping or whatever. Of course, next, create table. Okay, finish. So it will, it's easy as the Word file. You can delete those and enter whatever you want. You can add, insert row before this one. You can insert column. You can move. So can you imagine you are working with Word file. You can merge the cells. You can delete row. You can whatever. Most of the function in the Word file, you can do alignment. You can do, in case if in your protocol, if you are drafting your protocol using Graph Manager and you want to add table, you can add it here, and then just when I started add table, you have to mention where you want to add this table as additional table. Okay, let's move from the table because I added this since it's under tables. I want to cover the tables. So the most important is characteristic and then the risk of bias. Let's move to the figures. Oops. Can you go to the figures? So this is the figures. Can you, those they follow me, can you just click on the figures and then add figure? You can click here. So you see when I click here, it goes to the figures. Or right click and then add figure. It's the same. So when you add figure, What types of figure do we have in the risk manager? Forest plot, I cannot have it now. Still, I haven't done meta-analysis. Funnel plot, still I haven't done. Risk of bias. There is two figures of risk of bias. There is risk of bias graph based on studies and risk of bias summary. So I'm interested in both. Since I have done the scoring, let's just click this one and then click next. Okay, and then just finish. You see, created for me. I just did scoring. So you can see that third domain, I have 2 studies with high risk. So the color itself, but I don't know why it appears here not yellow, it appears white, but anyway, it's the same. It should appear yellow. I'm not quite sure what's the problem. So the first domain, it seems most of the study, it has low risk. So now I am interested into the other figure, which is, this is the summary I want to base on all studies. I select the other figure and then click next and then finish. So usually I use this, the risk manager to do this, the risk of bias. So you see 3 studies only. Those are the 4 domains or 6 domains, sorry. And here you can see the scoring. So the first study, it has just 2 high risk in 2 domains. The third study, it has 3, and so on and so forth. Okay. What figure I can add? Yes. Forest plot and funnel plot, I'll show you after analysis. If you want to draw, sometimes I draw Prisma here. You can do it here also. But sometimes I use the template that I added to the guideline. So you can also add flow diagram. Let's try Prisma here. So just flow. So you see, it's the same template. You can also right click and move up, move down, add whatever. You can write here. So I want to, you see here the addition. So I want to add 1 box below, top, whatever. So you can adjust whatever you need. I want to edit this. So edit, just click, right click and edit. So I want to write how many studies, number n equals PubMed. So I will delete all those. PubMed n equals to 245, and then just okay. So it will be saved as whatever. So it's as I told you, friendly user platform. Okay. So I'll go now, if you don't have question, to the last part, meta-analysis. Since already I have added the studies, but you need to really pay attention to the steps. How to do data analysis? It's from here, data analysis. I think I have covered most of the function here. Do you have any question? Because before I go to the last part, data analysis, any questions so far?
Is there any question? I think no question at the chat box.
Okay.
I proceed, Prof.
Okay, so data analysis, already I summarized. So you need to have some table like this one. You should have list of your study, here your intervention, and here your placebo. So for intervention, the main of all studies, standard deviation and n. If you don't have standard deviation, you have standard error, you have to convert. I think I provide you in the material software, it convert. And also I will show you now in risk manager, you can convert. Same for placebo. If you are doing dichotomous, it's the same, here intervention and sorry, exposure, and here it's an exposure. Or so here you should have number of events and n, only number of events and n. Same here, number of events and n, control. So the exposure control, okay, it has the same principle. So since I have all the data, it's easy to be added. So how I start data analysis? Go to here, data analysis. So you see the window of this content, it goes to data analysis. The first step to add comparison. You can add comparison by clicking here, or when you click at data analysis, you add comparison. Okay, so what's our comparison here? Statins versus placebo, let's say versus placebo for depression or whatever. You can write whatever works for you. Then click next. I'll go slowly, so for you, you can catch up. Okay. So now, what's the next step? You add comparison. After you add comparison, what you need to add? Do you need to add nothing, or add outcome, or add another comparison. So I will add outcome. So what's my outcome in this case?
Depression.
Yeah, but what's the score? How is it first? So you will come to this window. Is it dichotomous or continuous? I inform you there is other types of data. Usually it's not really we use it mostly. Yeah. So in this case, my HDRS, is it continuous or dichotomous?
Continuous.
Continuous. So I'll just select this and then go to the next. So here, what's the name of comparator? What's the name of the outcome? HDRS for depression or what? Whatever you want to write. So here, your experimental statins, and your here placebo, and then click next. You see, doesn't matter here because so this is the model, either to choose fixed model or random model, it's okay. Then main difference or standardized main difference. If it's dichotomous, it will appear as odd ratio or risk ratio, and it will appear. So at this stage, just leave it as default, do nothing, and go next. And here also, most of the time, usually for confidence interval, we prefer 95. Most of the meta-analysis, they calculate confidence interval based on 95 confidence interval. We don't go for 90, it's a bit low, and we don't go to, we are not strict to go up to 99. Okay, so just leave it as default, and just go, because you can change it, this one. So here, Dr. Norina, you asked me how I can put. So here, if you put in the left or right, you can decide it where you want to keep statin and where you want to put your placebo, or let's say your first intervention, second intervention. Okay, so it's okay. So which means that minus, it's just the direction. Let's use this one, statins. Do you want to? I will just follow the articles in order to see that final graph. It looks like the article or not. Otherwise, if I want statin positive, it should be here in the right. So I'll put statins. But actually, it seems the researcher who published that study, they don't understand the simple concept. If you read it, you will find too many mistakes, actually. So you can see sometimes even meta-analysis managed to publish, but in low impact factor with some mistakes. So how you want to sort the studies, to appear the studies, is it based on study ID, year of study, weightage, effect size? Just leave it as default. Later on, we'll see how they published and we'll follow, and then go to next. So now what's the next step? Do you remember what's the first step we added? Can you tell me what we have added? We have done 2 steps so far. First step we added. Anyone? Okay. Tell me the first step.
The intervention.
Is it so? I have done 2 steps. I have added the outcome and comparison. So the first step, is it the comparison or the outcome?
The comparison, yeah.
Yeah, the comparison. And then I have added the outcome. So the comparison is to compare between statin and placebo for depression. And then I have added the outcome, which is the HDRS, the measurement, how I measure the depression after the intervention using the HDRS scoring for depression. So now, and this outcome, is it dichotomous or continuous? I define this outcome as continuous because the included study, they reported the main difference. It's not odd ratio, it's not exposure, it's intervention, systematic review. So now you have different option here. What you need to do next? Are you going to add subgroup analysis? Subgroup, this is in case if you want to do subgroup analysis. Let's say you want to analyze based on gender, male and female, or you want to analyze based on other reason, or you want to add another outcome if you have another outcome. But in our case, I don't have outcome. I will add study to that outcome. Let's say in your included study, maybe you will have 20, but for this outcome, let's say for depression, you have 3 scoring. One is HDRS, the other one, it's another score, 3rd score. So it's considered the other score, considered as another outcome. But you have to add study to the first outcome first, and then create another outcome. I'm not quite sure, is it clear, the concept? So what I should add study for new outcome. So I click here and then continue. You see what are the studies that I added? Only here the studies under that I added under included studies. If I have added reference or studies under excluded, you remember I have added for you from PubMed under awaiting. It won't appear. Only studies, because now meta-analysis is just only for the included studies. So let's say if I have here 10 studies, but for HDRS only 3 studies. So I have to select only those 3 studies. So how to select? Just click and then shift on your keyboard and highlight the rest. Let's say if you have 10, then just click the first one, control, select the 3rd one, 4th one, whatever study you want to select for this outcome. And then you can create 2nd outcome, mortality or pain or whatever. So now I will do this one, and then I just click finish. It appears for me now, this plan. So since I have created, so you see, it's just 1 minute. Since I have created my data, I just copy and paste. It's the same design. When I design my data extraction, it starts with statin, placebo, mean, standard deviation, sample size, mean, standard deviation, sample size. And the arrangement, I should look, is it same? So 13, 14, 15. Let me just check 30. So I cannot copy paste because the arrangement of study, it's not, so I should copy paste based on 1 row, or I can amend that. Let me just go back to properties, the one that I told you I can amend later on. So I will sort the studies based on year of study. So 2013 will appear first. I will apply and then click OK. So I just reorder the studies, 2013, 14, 15. I am lazy man. I don't want to copy first study and then the 2nd study. I want all. So now is it the same sequence? 2013, 14, 15. But you can do whatever it works for you. How I go there? Actually, any amendment, you can just click here, the properties. So now I just click here and then just paste, and that's it. So the meta-analysis here, it appears. If I want this one to appear, just double click, just go to the first plot. So this is the first plot. Just click first plot. Does it look same? Not exactly, but let's amend it from here. We have skill here. To amend the study, you can increase or whatever. Let's go back and see the skills that they used for their study to have similar skill. So it's from -1 to 1, okay. But remember, I use fixed model. Can we see first, let's say, to compare the effect size. What's the effect size here? Can you tell me the effect size? I'm using fixed model, main difference. What's the effect size? Is it same like the published study?
No, 3.15.
It's minus. Yeah, -3. And the weightage, you can look at the weightage. That's why I told you, selecting the model, it will affect the weightage of each study. So can you see now the fixed model? Which study got the higher weightage? It's the 2nd study, because it has less standard deviation, so less variation. So sorry, for fixed model, there is 2 parameters for weightage. It's the sample size and then the inverse of variance or standard deviation. But for random model, it's the weightage only. So how I can change? So just this one to show you the difference between fixed model. It's really a change, the effect size. So how to change it? It's simple here. So this is the affect model. So that's why I told you it's easy. No need, just accept the default. So this is the random model and this is the fixed model. So just one click. Let's see the random model. And for main difference from here, this is the standardized main difference and this is the main difference. So for this study, they used which one, random and standardized or main difference? Can you check the first plot in the PDF? They use standardized or main difference?
Standardized.
Standardized. Okay, so now I'll just adjust this one to looks the same. So it has something like this. And then if you want to open first plot, this is the, you click here. This is the first plot. Does it looks the same? So because I put it, this is on left, it appears as negative, but actually I should put it here. But when you report the data, even if you do it like here, because you have two intervention, don't report the minus. Attach this one, but don't report minus. Effect size is point. Is it same effect size? Same p-value, same I-square, same confidence interval, or different as compared to the published article, published meta-analysis? Can you see the PDF and this one and tell me, is it same or different?
The same. They are the same.
Yeah. So you see the magic of meta-analysis, it's reproducible. So that's why if someone published meta-analysis or systematic review as a reviewer, I can repeat the same method, especially meta-analysis, within half an hour and see if they have done it in proper way or not. Or if someone wants to replicate the work, also they can do it. Okay. And I show you actually how to save it. So now I want, this is the first plot. If you want to save it from here, just save as. You can save it as different format, I think. JPG, whatever, PNG, and then just save it in. Okay. What else I want to show you? Yeah, if you want to add risk of bias to the same graph, you can add it here. So in the same first plot, it appears that as one figure, the risk of bias and the first plot with the data. And this is the interpretation of risk of bias. If you prefer to have risk of bias as separate, you can find in the literature, some they prefer to add both of them. Okay. Don't forget to adjust the scale from here. Don't make it too long because it will appear something like this one. With the arrow, so it's not in proper, and don't make it like this one, so it will be attached. So this is the best skills, something like this. And don't worry about the interpretation because they will look to the confidence interval here. It's not significant. It does not actually, there is zero, it's not here in the among the value. What else I want to add? The funnel plot. It's just one click here. So I just click. Why I don't have funnel plot? Can you tell me? The funnel, this is the plot, but there is no funnel. Can you tell me why?
Small sample.
Yeah, because it's not sample, small included studies. The included, again, we name it empirical studies, included studies. How many included studies for meta-analysis? Only 3. So you cannot do meta-analysis, funnel plot for 3 studies. You have to do fail-safe N. Believe me, I have seen as reviewer or editor, some meta-analysis with funnel plot for 3 studies, something like this. So when I look at the included funnel plot, I understand that they don't understand the concept of meta-analysis. So immediately I reject the manuscript, of course, not just only because funnel plot, because it seems they don't understand the whole concept of meta-analysis and meta-analysis, first plot, all those things. So don't do it. If you have 10 studies or 8 studies and more, then you can add it and then just look at the studies around the main. So this is the main here. Is it symmetric and not? And symmetric around the main, and there is few studies at the top of the funnel plot, which has higher sample size with higher precision, and few studies at the bottom. Why it has more precision? Because lower standard error. So when you go at the top, lower standard error. When you go at the bottom, more standard error, more variation. Okay, this plot between standard error and the standardized mean difference. So funnel plot, it's easy. So this is funnel plot. For what we use it? For publication bias or selection bias. Now sensitivity. Let's say I cannot do it for 3 study, of course, because meta-analysis, risk manager can, the minimum to do meta-analysis, it should be 3. So let's just add 1 study. I will, or let's try, yeah, let's see. Yeah, but you will not get data. So how to do sensitivity analysis? It's just only unclick. So let's say this study, it has high risk of bias, or it's not really having valid data. So I'll just untick and then run meta-analysis again. So I will look at the effect size. So the software, it does the analysis, but it's a bit strange. Of course, you can see the 3rd study is still there, but there is no effect size for that study. And this diamond, the final effect size, it's just only for 2 studies. So what's the effect size? 0.73, and still significant. So to us, it proves that even if we remove the study, the final effect size, it does not change. Let's add it. Do you remember? Can you tell me what's the final? Yeah, -73. Let's remove one of those studies. Let's remove this study. And then now it does not really give you a difference because it's just only 3 studies. If you have 10 studies and you remove one, you can see the difference in terms of, so it reduced to -7.1 instead 7.3. But still, so in this case, you can say, I have done meta-analysis, sensitivity analysis, and the effect size, it is still significant, reduced from 0.73 to 0.71, and so there is no difference. That's why I include the study, although it still have high risk of bias. Does it make sense to you now how to do it? So you see, I spent the whole day explaining the concept of the systematic review risk of bias. But when it comes to the software itself, it just takes 1 click to do funnel plot, or to do sensitivity, or to do other. I want also to introduce something. This is the final thing before I end, the calculator. I told you, if you have standard error, you want to compare to standard deviation, just click this function here. It's calculator. So let's say I have the mean is 16.7, and I have only standard error for this, which is 5.8. Then enter. So yeah, right, it does not. Actually, it should standard error 1. Let me just. But you need also to have the p-value. Let's have p-value 0.05 or 45. Then enter. Yeah. So this is the standard deviation. It calculates for you the standard deviation. So if you have the mean, the standard error, the p-value, and you don't have the included study, they did not report the standard deviation. And this is the case. Most of the included studies, primary studies, they just report standard error mean. For risk manager, we need standard deviation. I want to ask you, usually for your study, do you use standard deviation or standard error mean? Which one it reflects the variation? Standard deviation or standard error mean?
Standard deviation.
Yes. Yeah, that's why the risk manager, it compute the final effect size based on 3 values: the mean, standard deviation, and n. So if you don't have the standard deviation, just put the standard error, the mean, and the p-value, it will calculate for you. But I think I have included, if you don't use this one, I have included in the material other software or platform, it compete. I think it's here. I think it's Excel format. Yeah, this one, CI calculator. It calculates different things for you. So if you have other comparator, other outcomes, just go data analysis here, either add outcome or add comparison. Let's say my comparison still between statin and placebo, but I have another outcome. Just add another outcome. Is it continuous or dichotomous? And next, so it's easy step. Just name it between statin and placebo, and then leave this one default because you will change that later on. This one, studies, how you sort study, your label right or left, next, and then add study data. So it will bring you to the same included. You should have more included study. That's why certain outcomes, when you look at the meta-analysis, for the first outcome, maybe only 4 studies. The second outcome, 7 studies. The third outcome, because you can select here, I can select just only 2 study. It will create another figure for you. So you complete this one, you will get another meta-analysis. So hopefully, now after this demo for the risk manager, you are a bit more familiar with the different concept, random effect, fixed model. I know when I introduce all those concepts, it's a bit too much to digest. Standardized mean difference, mean difference. By the way, dichotomous, it has the same principle. It's much more easier. You have just only odd ratio and risk ratio. You need the percentage of event or number of event with the n number. Any question? Do you want me to repeat the data analysis or any question for the whole? Because now we are going to end the workshop. So hopefully with this, with today's workshop, hopefully at least the basics, the concepts of doing systematic review, meta-analysis, you have them. Again, I will remind you by the video that I show you during this workshop, you will get the knowledge. You can get the knowledge not just only from me, from tutorial, from Google, whatever. You can attend different course, but how to use, practice. When you practice, by the way, when I started systematic and meta-analysis about, I think 7 years back or 8 years back, I just attended few workshops, but because I'm interested, I practiced, I faced too many difficulties. So I learned from my mistake, I can say. And nowadays, I think most of my postgraduate students, I ask them within the first 2 semesters, while they are ordering the materials, while they are applying for the ethics, I ask them to write either narrative review or systematic review on their topic based on the relevance. So it's good exposure for them to learn the skills, and at the same time, they will understand their topic better, because when they draft their proposal, they just draft a proposal for registration. But when they write systematic review or narrative review, they will really understand. Sometimes they change their experimental design after they draft their review, after they publish their review. And the good things also, we can publish 1 or 2 articles within the first 2 semesters from just only from the systematic review. And it has more citation. Yeah. So do you have any questions?
Any questions?
Yeah, may I?
Yes,
Sure.
please.
Yeah. Excuse me, may I continue Dr. Nurina's question, Prof. Mohammed?
Sure.
So about funnel plot. So the place, the diamond shape left or the right side. So often the study, it's various conclusion. Some of them not significant cross the line. Some of them the position is right. Some of them position is left. So maybe if the content not starting with placebo, but 2 drugs, maybe MRSA, vancomycin, linezolid. So if the diamond shape is the left minus, so how we interpret where is the drug that affect the for our conclusion? how we interpret the data.
Yeah, just focus on the value of the effect size. Forgot about the minus. Is it minus or positive? Minus or negative or positive, it's sorry, minus or not, it's just only, it will tell you the effect size favor to which direction. I'll go back again to make it clear to the sorry. So this one. So for first plot, it should all the time, the left side should be minus. Minus here, it does not mean negative result. It's just only mean the effect size towards this here intervention, either second intervention or placebo. So let's say you are comparing between two antibiotics as intervention. Of course, the intervention that you will put here at the left side, if the effect size at this, the diamond at this side, it will, the final effect size will appear as minus. But when you report the result, you will report the value, not the minus, because the minus is the direction. It's not, it does not mean negative result. It means, so if it's minus 8 is minus 0.8. Let's say I'm comparing between vancomycin and augmentin for resistant, for MRSA, methicillin resistant Staphylococcus aureus. Which one more effective? Vancomycin or augmentin? And I put vancomycin here at the left side. And based on all included study, the final diamond, it will appear here, 0.9, let's say. But here in the result, it will appear as minus 0.9. So when I interpret, I will not say the effect size is minus 0.9. I will mention the effect size is 0.9 favor to vancomycin, which means vancomycin, it has more efficacy in killing as antimicrobial agent or bactericidal for methicillin resistant Staphylococcus aureus as compared to augmentin. So forget about the minus. That's why in this result, in the here, I can repeat actually this one, and I will put, if I wear this dorsal stertia, I put here statin and placebo here. So this diamond will appear here, but with the same value. It won't affect the effect size. It will appear as 0.73 without minus. Actually, we can do it now if you are interested, just to show you the difference. It's easy step, but it seems they don't understand the concept. Since you have asked, I think I will do it. I will just add comparison first. So it's statins versus placebo for depression. So this is the comparison again. So this is kind of revision for those they didn't follow me if I do it fast. So first I do comparison. Next, so I add outcome. The second step, so simple, a comparison, just one step. I add outcome. For outcome, I should decide, is it continuous or dichotomous? So continuous, and then what's my outcome? So here your outcome, it's the measurement, how you measure the efficacy of statin. So HDRS scoring, you can write whatever reliable, scoring for depression or whatever. And your experiment, what's your experiment or intervention is statins. And your control placebo, you can leave it as control or whatever. I will leave this one as default here. So I will, instead of left, I will put here placebo. You can see the difference now, placebo. And in the right side, I will put statin. Okay, next. So I will just add study data for the outcome. So 3 steps: comparison, outcome, study data. Continue. I'll just highlight those 3 studies and then just finish. Okay, and then just I will copy. If you forgot to sort them based on because you arrange your table, just go here. I'll go to the graph. I will just arrange them based on year or based on the weightage, whatever, and then click OK. So I have 13, 14, 15. Otherwise, when you copy one study by one study, because I'm afraid if it's not the same sequence, when you copy all, you will copy the result of this study instead of this study. So try to do it better. I think the best practice to avoid mistake, just copy the study first, and then copy the second study for me, because I am familiar with the software. So I do it a bit fast. Okay, so now just to show you the difference and how it takes. So I'll change the effect size to random and standardized mean difference. I will adjust this one a bit to have, but why it appears under placebo? Should appear, yeah. So actually it's, yeah, because you know what? It's considered, if you remember when I removed, I put statin here, but actually those data, it's for the placebo. I cannot amend this one. Let's show you. So the final effect size, it's the same. P-value, it's the same. But why it appear here? Because as default, under left side, all the time it should be the right side. All the time it should be the placebo. And here it's the experiment. If you look at the, let's do it again. Add outcomes, continuous. I haven't tried that before. Next. Yeah, actually the left side, it should be the experiment. So all the time you should put the experiment, while the right side is the control. But if you have two intervention, so the first intervention left side and second intervention intervention at the right. So even if I change, have you noticed I changed experiment to placebo, but actually by default, the software, it capture this one as experiment and this one as control, regardless what's the name. You can name control as baseline, you can name the control placebo. Even if you put statin, it will capture this one as control. So which means they are right when they created their this is where it's meta-analysis. Yes, they are right when they have done it. But my advice now, it's just only you will attach this first plot, but when you report if you read the result, when you report your effect size, they don't mention minus, because the minus here, it's not negative, it's just the direction. The left side, all the time, it's minus. If you read let's go back to the PDF file, where is the summary of the result of the effect size? In the result, I think. Actually, they put it minus, but it doesn't matter. It's here, it's not negative. They should report the value. So this value consider a bit moderate to high. And this is the confidence interval, and this is the p-value. But the concept, what I'm trying to say here, minus is not negative. It's just only to show us the effect size favor or towards the statin, which is on the left side. So if you remember in my slide, I mentioned about minus and plus. It's just to give us the direction to left or right side. It does not mean positive or negative result. We should look at the value and interpret the value.
Okay, thank you, Prof. So for the statin and versus placebo, it's the diamond shape in left or right. The interpretation still that statin affect the depression significantly.
Yeah. But to me, I don't think so. For a different reason, although they have published this systematic review. But if you read, we don't have time. Usually we go through the systematic review, and I ask the participant to critically appraise each step, including risk of bias assessment. You will find too many mistakes actually in the article itself. to me, I don't think there is really evidence. I'm not quite sure. It's based on only 3 included study. So really, we cannot conclude that those patients with depression, they can use statin. We don't have strong. If I have meta-analysis with, let's say, 20 studies and the final effect size is more than 0.8, yes.
Okay. Thank you, Prof. Mohammed. Thank you, Dr. Norina.
Yeah, welcome. We have one last question from Dr. Khairul. He asked, if we have time to event outcomes, how do we input it? Can you catch the question?
Yeah. So this is for odd ratio.
This is for hazard ratio, Professor.
So what do you mean by time? So are you referring to the same article, statin for depression?
No, it's different.
So what's the outcome here? Can you tell me what's the outcome?
Yeah, we maybe is for survival analysis or a length of stay. Maybe we need input the time to even outcomes. For hazard ratio, maybe we don't need this one, but hazard ratio, we can analyze it in OR or risk ratio, just only hazard ratio.
Yeah, odd ratio or risk ratio.
Yeah, but we have the data about the time to even outcomes. Maybe we can pull in one analysis.
Yeah, I think I told you there is also another. It's not just only dichotomous and continuous.
Yeah, I was wondering it can be.
I haven't tried that. For me, I have used only dichotomous and continuous data, but I think there is 2. Yes, here. So I think if it's survival, are you using hazard ratio?
Yeah, hazard ratio.
Yeah. So when you start yours, if you remember when I started, let's close this one. From the beginning, you should decide where is the. Let's see. Let's try. So close this one. Let's start. Let's go here. So just add outcome. Let's say the same comparison, but so generic other data. So any one of those applicable for you? Because I cannot say, when I read actually, yes, as you mentioned, we have to use hazard ratio, but for survival. So this is our data. It's not dichotomous, it's not continuous. But I don't know why. I can search for it for you. I didn't use it before. How to do it with Risk Manager, because it's not among the list here. I think this one is different. Let's try this one. Variance. No, I think next. To odd ratio. So it's not. Let's try the other one. Generic inverse variance. There is information. You have to read also those information. So odd ratio, risk difference. So more to dichotomous, and this is more to continuous. So really, I'm not quite sure. But by the way, it's not just only Risk Manager. We use it for meta-analysis and comprehensive meta-analysis, CML. Some they use certain programming like R or Python to do meta-analysis. So it has more function to do that. And also, I forgot to mention when I explained during my presentation, there is also, it doesn't go. Sometimes we have to do some statistical analysis after we compute the, where is it? You can do one way and off, you can, let's say if you have different outcomes, I think I missed that, yeah, here. So let's say you have one effect size you are comparing between 3 intervention or 4 intervention. You have to compare between the first 2 intervention, you will get effect size, and then do the same procedure for another 2 effect size, two interventions. And then you can do one-way ANOVA or multiple regression to compare between the 4 intervention. So it's not just only, now I just explained how to compare between 2 intervention or intervention and placebo, but there is actually the other function you can do it. So for that, I'm not really quite sure. Perhaps I'll check and get back to you. But it's you should use hazard ratio. I cannot see it here among the list.
It's fine.
Yeah. But maybe I'll check if Risk Manager can do that, or you have to use CML or R programming or other platform to do it. But sometimes, do you think you will be able to convert, if you will be able to convert your the data of included study to event or to risk ratio or odd ratio or percentage, then you have to do it as dichotomous. Sometimes we can compare, same like statistical analysis using SPSS, we convert our, what they call it, our primary data. But really, I'm not quite sure.
Thank you.
Yeah.
Thank you, Prof.
Any other questions? Yeah.
I think no more question, Prof. And it's already 4:11.
Yeah.
We've been late quite
Yeah,
long.
I exceeded my time, so sorry for that, but I
No,
tried my best.
no,
As I told you, this workshop usually I conducted in 2 days. That's why when you have contacted for first time, I insist for 6 hours, because I know it needs minimum 6 hours.
Yes, yes, Prof.
Yeah. So wish you, just the last word, I wish you all the best in your career, in your research, in your teaching. I am open for collaboration if someone interested or have certain topic, but if it's relevant to my area, I will collaborate. But if it's not relevant and you face any difficulties, just drop me an email. I can help you, guide you, but I will not be part as author if it's not related to my area of expertise. So wish you all the best and thank you for your attendance.
Very great, Prof. You too. We all wish you all the best. Always be healthy. Always having a good, what we call it, a good performance on your research, on your publication and teaching and so on. And but now we've come to the end of this, what we call this great workshop from that is delivered by a great speaker. I think I need to sum up some important things that from your explanation, we now understand how important is the systematic review and meta-analysis. And I'm quite sure that even mostly we are still in the basic level, but I know that you have been succeeded to upgrade us. I mean, to get more knowledge and more motivation to do the systematic review and meta-analysis, because, well, actually it is quite simple, as you said, that it comprises of some steps: identification, and then selection, appraise, and synthesize. And you also have shared so many resources for us to learn more, and hopefully that we can share the recording of this one-day workshop. And of course, because it is also doable even in the situation of the pandemic, where sometimes we need to restrict our activities, even in the lab. So it is doable, of course, and it is highly cited. So for us in UNAIR, it it is important to do to boost our research activities and publication. And I'd like to take opportunity to extend our gratitude to our honored speaker, Professor Dr. Muhammad Abdullah Mahdi Al-Shwash, for taking your valuable time and put so much effort to add our knowledge and to upgrade our skill in doing systematic review and meta-analysis. And we all look forward to meeting you at our future events or collaboration in doing systematic review or meta-analysis or of another area of your expertise, because we know that you are expert in about animal lab and also in toxicological studies and of course the molecular pharmacology. I think and also thank you to the head of department and to all the committee. Alhamdulillah, we have come to the end of this session, and hopefully Allah will bless us with more knowledge and of course more beneficial knowledge that what we call that we can do it and we can do it to produce more research, especially in systematic review and meta-analysis. Thank you. Thank you, Prof. For the committee, I think the screenshot of this one-day workshop has already got, and can I end this workshop now, right? Thank you, Prof. Thank you.
First, Mbak Nurina.
Yes.
Can we take a picture?
Oh, yeah, great. Can all the participants do on the camera? I'll try to make it gallery.
Okay. Okay, then sorry for the back sound, the chicken. Okay, let me take your picture. 1, 2, 3. Okay. Thank you very much, Professor. I will send email for you after this. We are very grateful for you to join with us for today. Thank you very much.
Yeah, thank you.
Thank you.
Thank you very
Okay,
much,
have a nice day.
Dr. Muhammad.
Bye. Stay safe.
Thank you very much, Prof.
Thank
you, bro.
To all the best. Assalamu alaikum.
Waalaikumsalam
Warahmatullahi wabarakatuh.
I will end this Zoom.